Okay, good morning, everyone. How did the homework go? Any questions? Okay, anybody beside the Chris? All right, so we do 39 and then we proceed. All right, so I'll read it. So we have the following. We have the graph of y equal 1 over square root of x, y equal to 0, x equal to, x equal to 6, about the x-axis. Okay, right, so first we graph always because I have no idea what's really going on in here. So this is y equal 1 over square root of x. This is going to be a graph. It's like 1 over x almost. So this is 1 over square root of x. And y equal to 0, that's the x-axis. X equal to 2, that's this horizontal line. And x equal to 6. Okay, so they give us basically everything. And this is the region I need to rotate. So I'm going to rotate that region and that region here. Okay, we're going to get this kind of picture right there. Okay, so you have to find the volume of this picture. All right, so we're going to do it the way we always do it. So I'm going to sketch the graph again and take a slice and rotate and see what is going on. Okay, so that's really what's happening. So we do this problem. So this is my graph. This is 2, and this is 6. And this is the axis of rotation. That's the x-axis. So now we're going to take a typical slice. So that's my typical slice. Typical rectangle. And I'm going to rotate it. Okay, so we're going to take this one and rotate. So that's the axis of rotation. And this is the rectangle I need to rotate. I rotate on the side because I leave this picture for labeling. So we understand this. So this is my rectangle. That's the axis of rotation. When I rotate this rectangle, what I'm going to get? Immediately, the first question usually is when I rotate, what I get. So rotate a rectangle. Rotate a typical rectangle. This will give me a what? Quickly.
Disk.
Disk. There's no washer in this problem. There is no hole. No hole at all. So we're going to get actually a disk. So it's not even a washer problem. That's really belong to previous one, which is a disk problem, which is okay. So for a disk to be able to find the volume of a typical disk, I need the radius and I need the thickness. So if I call this my xi, we know the radius is from here to here. That's my radius. So that's going to be the radius of my disk, which is, this is the function y equal 1 over square root of x. Means if this is, I call this xi, from here to here, I have 1 over the square root of xi. That's the radius. And that's the height of my disk. Is a very, 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 it's a disk. So the thickness, this is very tiny. That's the delta x. Okay. So now radius is nothing more than 1 over the square root of xi. The height is the delta x. So volume of a typical disk is pi times, that's not a washer, radius square times the delta x. The radius square is 1 over the square root of xi. And the idea is when we cover this with rectangle and we rotate every one of them, I'm gonna fill up my volume with basically a bunch of disks, like one against the other, one against the other. That's really what we're doing. We're covering this with disk, one against each other. So the total volume is going to be the following. To cover this whole region, I need to divide this interval. So it's gonna be from 2 to 6. I'm adding the volumes. So I divide, add volumes. The volumes, these are the volume I'm adding. So it's going to be pi 1 over the square root of x squared dx. Okay. And now we integrate. Will give me integral from 2 to 6. Pi is a constant. I can get it out. 1 over that is 1 over x dx. Now, antiderivative of 1 over x, that's the ln between 2 and 6, which will leave me with pi ln of 6 minus ln of 2. Okay, and that's really plenty. All right. Any other questions about the washer? It's your chance to basically get this going. Usually I assume if you don't have questions means you did the homework. That's the way I work. All right, so crucial that you ask questions. So we're gonna keep going along the same line today, but with a little bit of a change. So what we're going to do is the following. And hopefully we'll do a lot of problems there. Okay. Revolving, we're gonna revolve, but about horizontal and vertical lines other than the coordinate axis. Okay, so every time we've been rotating about the x and y axis. So now we're gonna rotate about axis, but not vertical and horizontal. Otherwise, if it's slanted, it's actually kind of hard. So we will restrict to horizontal and vertical, but other than the coordinate axis, not necessarily the coordinate axis. So this is my first problem. Okay, so let R be the region bounded by the graph of, very simple graph, y equal x squared and y equal the square root of x. And the question is, find the volume of the solid obtained by revolving R about. So we're gonna take different axes. The first problem is about the line y equal -1. Okay, so you guys are writing down and then we do it. Okay. So regardless which problem we're doing, we sketch. I mean, without sketching, I don't know what to do. So the region bounded by y equal x squared, y equals square root of x, these are simple regions. So I'm going to sketch always, just to have an idea. So y equal x squared is this parabola. Y equal root x is this graph up here. And the new thing is that my axis of rotation this time is the line y equal -1. Means this is -1 down here. Okay, and this is my axis of rotation. That's the axis of rotation. So this means that you don't always have to rotate yourself, but since we're doing it, it means that's, I'm going to rotate around this one. So this is going to be something like that. This would rotate here, and that's really my huge cavity right there. And this is going to go down here, very down. And this is going. So that's really the region I want. And there is a huge cavity in the middle. Okay, so that's really what we are after. So we're gonna do it the same approach. We do not change our approach at all. I'm gonna cover the region with rectangle and basically rotate every one of them and fill this the solid with those rotated rectangle and find the volume of each one of them. So my logic will not change at all. So now it's time for a good picture so that we can label it very well. So now I draw the picture again and on my typical rectangle and I rotate it and see what's happening. So now we do the work. So these are my two curves. So my upper curve is the y equals square root of x. My lower curve is the y equal x squared. And now the line of rotation. So y equal -1. We're rotating around this line. Okay. All right. Now, if you do that, we're going to do the same approach. That's my 0. And at the intersection point, of course, I need the intersection. Intersection is not hard here. I'm going to set, we've probably done it several times, equal x squared. I square both sides. I get x equal x squared, give me x4. x4 minus x, we always put it equal to 0 to solve. We factor out. We get x equal to 0, x cubed equal to 1, which will give me x equal to 1. So these are my intersection points. So this one is 1. Of course, if I plug in 1 in this y, in the y for the upper curve, I get 1. In the y of the lower curve, I get 1. So this is definitely where they meet. Okay. So now we're going to, as I said, the same. I'm going to take, this is 1 for me, and I'm going to take a typical rectangle. That's the rectangle. So basically focus on this piece tremendously because it's basically my rectangle is something like that. It's a thick line. That's really what it is. But let's make it a little bit thicker so you see that the delta x is very small. So that's really my rectangle. Okay, and this is my delta x right here. Very good. And so my xi, my typical rectangle. Now let us be very, very careful here that we're rotating around the line y equal -1. That's really the new thing. That's my rotation. So when I'm rotating it, the center, first, are we gonna get a washer or a disc? Question number 1.
Washer.
Washer. There is a huge hole. Now, what is the center of the washer?
Y equals -1.
What?
Y equals -1.
Right. The center of the washer is going to be right here. So when I'm going to rotate, that's the smaller disc. And basically, that's the upper disc. That's what's happening when I'm going to rotate. Of course, it's going to be a disc. So if I do it on the side, okay, you can do it on the side. You don't have to. But if you do it a little bit on the side, this is the piece that I am rotating. It's very, very thin. I mean, barely you can see it. So I'm going to rotate. I'm going to get that. And I'm going to get this, something like that, with a washer. That's it, kind of a washer like this. So I'm going to get this kind of a washer. With a little bit of a thickness. Okay, that's what we're going to get. Now let us analyze every piece. What is the radius of the washer? So the center of the washer is crucial. Crucial here, the center of the washer is on the line. The center of the washer is on the line xy equal -1. That's where the center is because I'm revolving around it. So what is the inner radius and where is the upper radius? The outer radius and the inner radius. Okay. I'll give you 2 minutes to think, a minute to think, all of you, I want you to think about it. Rotate rectangle. Give me a washer. I need the volume. I need the inner. I need the outer. and I need the height. Okay, all right. What is the inner? Remember, that's the center right here. So who can tell me what the inner is going to be in word than the formula?
Is it x squared plus 1?
Yes, because it's from where to where? The inner from where to where? Can you say it in word the best you can?
From y equals -1 to...
You're right, to where?
To the y equals x squared.
To the bottom curve, exactly. The radius is from where to where? It's from the here all the way to the bottom curve, right there. That's my radius, the inner one. Okay, so we just shifted down. So when we did with respect to the x, when we revolved around the x-axis, the radius was from the x-axis, because that's the axis for revolution, to the bottom curve. So it was xi. By shifting down, we increased the radius of the washer. And we basically increased it by 1. That's really the picture that we're working with right now. So we increased the rates by 1 because we actually shifted the axis of rotation 1 by unit. So that's really the inner radius from the bottom, from the axis of rotation all the way to the bottom curve in this case. So now we look at the picture again. What's the distance from here to here? If this is my xi, this really here is the xi squared. That's really, I think about it. So how much we have from xi squared to -1? So the inner radius is xi squared, that's the highest value, plus 1, large geometrically, or some students like to say minus the lowest value, the upper value minus the lowest value. Or you can look at the picture and say, you know, it's xi plus 1. It's up to you. Plus 1. Use the picture. Always use the picture, and you will be okay in those problems. Plus 1. Okay, so it's the distance. From is the vertical distance. In this case, from y equal -1 to the bottom curve. Now, what's the outer radius? Again, I want you to look at the picture carefully. Think about it. And what's the outer curve, the outer radius?
Is it square root of x plus 1?
Exactly. Do you agree with him?
X and y.
Yeah, it's the distance from. So the outer radius, I will draw it from this side. That's the outer radius. It's from the outer curve, basically, or the upper curve, all the way to my axis of rotation. That's my outer radius. Okay, it's from, so this is xi. That's the center. It's from here to the top curve. Absolutely there. Now, if this is xi, this point up here is basically the square root of xi. So what's my radius? It's from here to here. So it's going to be the square root of xi plus 1. Okay, so again, if we are rotating around the y-axis, the outer radius will be from the y-axis till the upper curve. But since we're shifting down by 1 in this case, it's going to be that plus the 1. That's the picture we're doing. Now the height is this little delta x. It's very, 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 very tiny. It's this little bit. So it's like as I said, it's like you can think of this of washer as almost like a quarter where you hit to make a big hole in it. So it's very, very small thickness at this stage. So now the volume of a typical washer. So that's now we have everything. Actually, we're done. Once we do that, we're done. Volume of a typical washer. is equal to pi times the outer radius square minus the inner radius square times the little height. So I rewrote the formula to remind you what it is. So this will be equal to pi times the square root of xi plus 1 squared minus xi squared plus 1 squared delta x. And now the volume of the whole solid. So volume of solid is going to be the integral. And whenever I write integral, upper and lower, I have to think about them, even though they are most of the time easy here, but we have to think about them. And the way we think about them is which interval I have to cut to pieces to cover my region. It's from 0 all the way to 1, because to get my whole volume, I need to cut this whole region into pieces and rotate each piece. So this will give me the integral from 0 all the way to 1 of the inside. This is the idea of adding those volume. At this stage, we are adding those volume. Pi is a constant, I get it out. Square root of x plus 1 squared minus x squared plus 1 squared dx. And the last step is to integrate. How do we integrate this? If you are doing it.
When we first square both of the equations.
Yeah, there is no other way. We have to distribute this, which is going to give me square root of x squared, which is x, plus 2 root x, plus 1, minus x squared squared, x4, plus 2x squared, plus 1 dx. And the rest becomes simple integral, because the rest will become between 0 and 1. We do each one. Antiderivative of x is a half x squared. Antiderivative of square root of x is 2 times 2/3 x to the power 3/2. Basically, this one and this one will eventually cancel each other out, minus 1/5 x to the power 5 plus, minus, because I need to distribute, 2 times 2/3 x cubed. And then the rest, you do it, is simple. End of the problem. Okay. Right, now we're going to work with the same problem, but we're going to change the axis of rotation till you get fairly comfortable with the concept. So problem number 2 is the following.
Professor?
Yeah.
How come you didn't take the antiderivative of 1?
Because they will eventually cancel out. Plus 1, minus 1.
Oh, okay. Okay, thank you.
I could have, but it doesn't matter. Okay. Very good. Are you guys done with this? Can I move on?
Yep.
Yep. Everybody? Okay. So now I'm going to take the same region. So I'm not really going to change the region. I'm just going to change the axis of rotation. So problem number 2 is going to be the following. So R, the region, R, again, region bounded by the same thing, y equal x squared, y equal root x. And then we're going to rotate about the line y equal to 1. So example number 2. And the question is, find the volume of the solid obtained. Now, for this one, I'm going to give you a little bit of time for yourself to think through that. So this is the picture. I drew it. My upper curve. No, sorry. I'm going to go down a little bit.
Can you move the paper down a little bit so I can see the top? Oh, thank you.
It's the same region as before. I didn't change my region.
Okay.
Got it?
Yeah.
So now I can move down, everyone. Okay. So I'm going to take the region. I will draw it again. So this is my upper curve. This is my lower curve. The intersection point is 1, 1. The axis of rotation is y equal 1. So we have to be very careful and draw it carefully. Y equal to 1, that's 1. And this is my axis of rotation. Okay. All right. And so we're rotating it this way. So that's the rotation. Something like that. All right. Now the question is, what's the value? What is the value obtained? The logic will never change at all. I never change the logic, but the picture is going to change. So this time, so this is my interval 0, 1. And I'm going to pick typical xi. And, you know, when you guys are taking your quizzes, you have this tendency to pick sometimes xi here. You don't take extreme cases. Xi should be somewhere in the middle, so you have the correct picture, or you actually will not work for you. So this is now my rectangle. Okay, but now we're gonna rotate around the line y equal to 1. So we're gonna rotate like this. And this is gonna be rotated all the way up here. So that's really the base of my washer. We're rotating the other way around. All right, now I'll give you a minute, 2 minutes actually. Each one of you figure out what's gonna be the inner radius, figure out the outer radius. Remember, this is the center of the washer. The center of the washer is right here on this axis. Okay, now I'm gonna keep quiet and
Wait,
let you think.
So you're
What?
saying so you're saying that whatever's inner and outer is always in reference to the axis of rotation?
Absolutely. Think about it. Can you understand why? Because we're rotating around this line. The center of the washer is going to be right there. Did you follow what I said?
Yeah, that makes sense.
Yeah, that's where the center of the washer is going to be. So everything is with respect. We have really to think about the axis of rotation. Because we're rotating about this line. So imagine we're rotating like this. We're rotating this way. So that's the axis of rotation here. So the center is here. To find the radius, I have to find the distance from the center to the edge. Get going. And every day, lesser students are turning on their camera. Please turn on your camera. I hate to keep bugging you with that. Okay, please, those who have it on, please turn it, have it off, turn it on. Okay. Right, let's see. Any ideas? I'm gonna pick one student, and if he has an idea, fine. If he doesn't, just tell me I don't. So we work on it. Dylan, do you have any idea?
Is the inner radius the square root of x plus 1?
What did you get? How did you, the inner, you're talking about the inner. So all of us gonna focus on the inner. Tell me on the picture, from where to where? If you can, the
So-
best possible way.
So I don't even know how you would xi at the corner of the rectangle.
Which corner? The inner one.
The left,
Upper
the
or
left.
lower? Let's call this, let me call this a point A if you want, so we can talk. And let me call this B. Okay?
So point B, it would reflect over the x equals 1.
Y equal 1, be careful.
Or
Y-
y, yeah, sorry.
That's
Y
fine.
equals 1.
Yeah.
And then reflect over.
Right.
So wouldn't that be x, the square root of xi plus 1?
Think about it, but first of all, in words, it's from where to where? From the point, which point? It's the vertical distance, from which point to which line? Is it from the point A to the, I don't know, from which point to which lines, which vertical distance? Do you understand what my question is, though?
Yeah. So
Okay.
it would be from point B to the.
What is the center of the washer? This is the line. Think about it. Forget about the rectangle. Think about a line also, only, this line. And rotate it around this. Okay, think you're taking this line, this little line here, and you are rotating it. You take it and you rotate it. So think about this. This is the line right here. This is a line. Think about the line only, not the whole thing, to make it easier. Think about this line. Okay, and this line. And then you rotate it about y equal 1. What's going to happen? You're going to rotate. So it's going to go like that. And it's going to go like this. So you're going to have this hole in here. So the inner radius is going to go from where to where? From here all the way to the line will equal to 1. This vertical distance. So the inner radius is going to be from the point B, is the vertical distance from the point B all the way to the line y equal to 1. So it's going to be this one from here to here. This is the inner radius. Okay, so it's the distance from the point B on the upper curve all the way, so that's the inner radius from here to here. I stop. Dylan, didn't make any sense?
Yeah.
Okay, now let us find it. Let's find this is equal to what? Again, I wanted to look at the picture. I totally wanted to look at the picture. This is the point B. What's the y coordinate of the point B? If this is xi here, this is the xi. It means from xi till the point B, this point is on this curve. Square root of x. So this vertical distance from here to here, if this is xi, this is going to be the square root of xi. And the inner radius basically is from here to here. From here to here. Now, do you feel comfortable to give me a formula for the inner radius? Basically, I'm finding this distance. From here all the way down here. That's the inner radius. Okay. Remember, if you have any 2 points on a vertical line, any 2 points on the vertical line, any 2 points, let me call them C and D. Any 2 points, the distance between them is always the upper value minus the lower value, whatever the points are. So what's going to be the inner radius here? 1, not plus, minus the square root of xi, this little distance from here to here. Okay. The outer radius. Okay. I'll pick somebody else for the outer radius. Ryan? Ryan, do you have idea? Do you have an idea?
Yeah, it is 1 minus x squared I.
Yeah, so it's from where to where on the picture? In terms of the way we're talking about it, from which point to which point on my picture?
It's
the vertical.
A.
Mm-hmm.
Sorry, it's from 1 to A.
Right, it's from A all the way, it's this vertical distance. It's from A down here all the way to the line y equal to 1. This is the outer distance, outer radius. Now, that's the point that I want you to understand. This is the point on the lower curve. It means if this is xi, the y coordinate of this point is xi squared. I want this to be very clear. This is the curve y equal x squared. It means whatever you pick here, whatever name you give to this point, from here to here you have xy squared. So the outer radius is from here to here. That's the outer radius. So it's going to be 1 minus xi squared. And the height is this little bit of delta x. Once you figured those 3 items, you are basically on your way. The problem becomes now simple. So volume of a washer is going to be equal to pi times the outer radius square minus the inner radius square times the delta x. So finally, it's going to be equal to pi times the outer 1 minus x squared square, the inner 1 minus that. And now the total volume. Again, to cover the region, it's from 0 to 1 of pi times dx. So it's 1 minus x squared minus that. And now the integration is verbatim like the integration in the previous problem. So it's going to give me integral from 0 to 1 of 1 plus x4 minus 2x squared minus 1 plus the square root of x squared minus 2 root x dx. Okay, and the rest, I think it's simple. None of those pieces is hard to integrate. x4 is 1/5 x5, x squared is 1/3 x cubed. 1 will, in this particular problem, also will cancel out. This is half x squared, and this is, should be, we've done it a million times, this should be 4/3 x to the power 3/2. So the rest, I will let you finish it. Okay. All right. Again, I'm going to work with the same problem. I'm not going to change the picture. I'm going to change the axes of rotation. Make it a bit harder. No, not really. Okay, all right. Just really boil down to understand what the graph means and how to work with it. So, my last problem for today is, again, the same region. So R is the same thing. R, example number 3. R is the region bounded by y equal x squared, y equal square root of x. And we're going to revolve around, this time, around x equal to 1. Very careful. The question is, find the volume. Find volume of the resulting solid. So I will draw the picture and I will start, asking you to give me ideas. So the region is the same, so we don't have really anything for the region. So we're going to draw it here. It was upper curve, lower curve, the same thing. This point here was 1, 1. So that's the square root of x, and that's the x squared. And rotating around x equal to 1. So remember, x equal to 1, that's a horizontal line. And this is 1. So this is my axis of rotation. That's 1. So let's change its color so it's right there. Okay. So that's 1. So the axis of rotation now is basically parallel to the y-axis. So we are going to take horizontal slices. So this is my slice. Horizontal. Now, when we're taking horizontal slices, y become my variable. Y is going to become my variable. Okay, so we're going to cover with horizontal slices. And now when I rotate this horizontal slice, so rotate horizontal slices. If I rotate this, of course, around the line x equal to 1, I'm going to again, we're gonna get a washer because there is a big hole in here. So we're gonna get a washer. And this case, the center of the washer is on this line. So here where the center of the washer on this line. Because when we're gonna rotate, we're rotating around this line. So it's gonna be the center of my washer right there. Okay. So now I'll have to let you interpret and interact with this problem and see what you guys come up with. The inner radius from where to where, the outer radius from where to where, and what's the value of the inner and the outer. Okay, I'll give you again a minute to start interacting. Think picture, think pictures, no memory. Every one of you should try it. Every one of you to understand it. Anybody feels comfortable?
I think I got
Yeah.
something.
Okay, go ahead. One of you, I don't care. The second one, who spoke? Go ahead.
Yeah.
I don't care, just go ahead.
All right, so radius of the inner is 1 minus x squared, and radius of the outer is 1 minus square root of x.
Okay.
Which is the top curve square root of x?
Okay, this is y equals square root of x.
Yeah.
Okay. Now in words, don't tell me formulas. Okay, I don't want formulas. From where to where is the inner radius?
Okay, so I guess from the inner, from the center line to the right side of the
Here?
yeah.
Okay, so let's give it a name. That's the inner radius. From here to here. Is this a vertical distance or a horizontal distance?
It's horizontal.
Horizontal. Very good.
Wait, don't we have to convert the top
Absolutely.
curve into
Right. Go ahead.
x equals y squared?
Yes, we have to express x in terms of y. Why we do have to do that? Let us think very carefully. yi is from here to here, correct? That's yi. If you want the distance from 1, do you want this horizontal distance? That's the inner radius, and you're absolutely correct. But how can I compute this horizontal distance? Basically, I go up here. I want the distance from here to here. That's really what I want. That's not an x. That's not xi squared. I mean, I know that this is y equal x squared. From here to here, that's not the xi squared. It's the x that correspond to this yi. So what I have to do first, I have to express every curve. I have to express x in terms of y. So y equal x squared will give me x equal the square root of y, because I'm looking for this horizontal distance. So if this is yi, I need this horizontal distance. It means I need the x that correspond to the yi. So if this is yi, this point here, A, if this is yi, the first coordinate is the square root of yi. That's the coordinate of the point A. Means down here, I have the square root of yi. I need this horizontal distance. That's my inner. Okay, it's crucial. We have to write x as a function of y. So my inner here is going to be 1 minus the square root of yi. Why I need to express x in terms of y? Because I need a horizontal distance. So if I know yi, the horizontal is given by the x that correspond to this one. Crucial. Y is my variable in this problem. Y is the variable. In my mind, I'm dividing the interval on 0, 1 along the y-axis into pieces. So this, if you want, now this is a delta y, not a delta x anymore. Okay. What's the outer radius?
1 minus y squared.
Yeah, do you agree with him? We have to solve. If y equal root x, x is y squared. Crucial. I have no idea, no way out. So the outer is going to be from, this is going to be the outer. From the, in this case, is from the left curve all the way to the line y equal to 1. That's going to be my outer. So it's a horizontal distance. It's a horizontal distance. So it's going to be what? If this is point, let me call this point B. So the point B, I know the yi. So the xi is yi squared. That's really what the point B here. So in my picture, if this is yi, that's the point on this curve. It means this right here, that's the yi squared. That's the horizontal distance. And I need that piece. So it's going to be 1 minus the yi squared. Okay. What's the height here?
Change in
What?
change in y.
Delta, change in y. Delta y. Be careful. Delta y. Y here is the variable. Y is the variable. I know that we've never done something like this, but you have to start getting ready. Okay, y is my variable. So now, volume of a washer, I'm done. Is pi times. Now you don't mix the x and the y in the same integral. Either it's an integral in y or an integral in x. If it's an integral in y, everything has to be expressed in terms of y. You cannot have y and x at the same time. It doesn't work. So it's the outer minus the inner. The outer, the inner. So finally, the total volume. It's the integral. Now, y is my variable. So I go back. This has to go from where to where. Now they happen to be 0, 1, just by coincidence, they don't have to be. But to cover this with those slices, I have to divide the interval from 0 to 1 on the y-axis. It's going to be integral from 0 to 1 of pi times 1 minus y squared squared minus that squared, and that's the dy. So finally, my pi can go out, and I will have the integral from 0 to 1 of this. Now, like we did before, I have to distribute. I will get 1 plus y4 minus 2y squared minus. I need to distribute that. I get 1 plus y minus 2 square root of y. And the rest is not hard. You guys can finish. Okay? Right? And so please I forgot to assign the homework last time. I'm going to assign it right now. So you give me 15 minutes to do it. Please do the homework. You will not learn the stuff without doing the homework. And as I told you before, the lectures for this section, it is on Brightspace. It means my notes are on Brightspace. So in the content page, you know, there is notes from the class. So then my notes are on Brightspace. I don't know if you're looking at them. It's really up to you. But in case, you know, you want, so the notes are right there because I'm not doing it exactly like the book is doing it. Okay.
Will you always have the notes on Brightspace?
What?
Will you always have the notes posted on Brightspace?
I will see, maybe. If you guys do well, I will. If you guys don't do well, I won't.
That works. Thank you.
Okay? This is the deal.
Understandable.
All right? Got it?
Done.
All right, so right now the lectures are on Brightspace. You can look at them. I mean, I hope they are clear. And please do the homework. Please do the homework. Do you hear me? Okay. Any questions?
Have a good day.